Welcome to my video on transformations. So to answer your question that's probably in your head already, what is a transformation? I'm going to give you 3 of them, okay? And I will talk about each of them individually. So the first transformation is a translation. A translation is a shift. When you take a diagram or a letter or a graph or even something as simple as just a line and you shift it, you move it to the right, you move it to the left, you move it up or down. Okay, that is a translation. Number 2 is a reflection. So when you look in the mirror, you see your reflection. Okay, I can give you a line and ask you to reflect a diagram over the given line. I can ask you to reflect a letter over a given line. Okay, so number 1 is a translation, number 2 is a reflection. Okay, number 3 is a rotation. So what is a rotation? A rotation is when you take something and you turn it, you spin it around. That's a rotation. Now, I know I really haven't explained too much about what a transformation is, except to say that these are 3 different types of transformations. Here's what's important to know about a transformation. A transformation maintains the size and the shape of a figure. So when I translate something or reflect something or rotate something, it does not get bigger. It does not get smaller. It keeps the exact same size. Secondly, it keeps the same shape. So if I take a square and I shift it over to the right, it's still a square. If I take a circle and I reflect it over a line, it's still a circle. It doesn't change to a triangle. Okay? If I take something, say a triangle, and I turn it, it's still a triangle. Okay, to save some time, I've already pre-written the examples. So let's explore what a translation looks like. Now remember, translation means to shift. So example 1, I'm asking you to translate point A 3 units to the right. So what does that look like? That's 1, that's 2, that's 3. Here's my new point, and typically after you perform some kind of transformation, you use the same letter, but put a little tick mark next to it. So when I translate A, 3 units to the right, it goes 1, it goes 2, it goes 3, and becomes A prime. Okay, second example, take point A and translate it down 2. So down 2 looks like this. And then left 1. Left 1 puts me here. So here becomes my new A prime. Okay, and those are both examples of translations. So now it's time to talk about reflections. Remember, a reflection is a mirror image. So I could have a mirror image over a vertical line of symmetry. I could have it over a horizontal line of symmetry. I could have it over a diagonal line of symmetry. Okay, here's 2 examples. Maybe take a second and think about what would the reflection over each of these lines of symmetry look like. Pause the video now here if you want to try it. Okay, so bear with me, these are about as good as I could get, but take a look. When I reflected the letter B over my vertical line of symmetry, I still have the letter B. Now, it is a mirror image of it, but it didn't change to a P or a C or a Y or some different letter. It didn't change to a square. It's still, you can still recognize the letter B. Okay, secondly, and very importantly, this space here and this space here are roughly the same. The size of this letter is roughly the same size as this letter. I mean, to your best ability. But these are the things that have to hold in a reflection. Okay, the size and shape has to stay the same, and the spacing between the figure and the line of symmetry has to be the same on each side of the line of symmetry. Same thing here for the number 5. Okay, the 5 is still resembling a 5. It doesn't change to a 12 or a 3 or a 4. It's still a 5, and this space here is roughly the same as this space here. So I saved the best for last. Let's take a look at how to do a rotation. Now remember, a rotation is a turn. Okay, you can't turn an object unless you know what point you're turning it around. Formally, when we talk about rotations, we don't actually say around, we say about. Rotate about the given point, rotate about the origin, and so on and so on. Okay, to be able to do a rotation, you need 3 things. You need to know clockwise or counterclockwise. You need to know how much are you rotating the figure, and you need to know where are you rotating it about. Since we know all 3 of these things, we are ready to start. So first, let's talk about what it means to rotate clockwise. Clockwise is that direction. Okay, 90 degrees, we know what 90 degrees looks like. 90 degrees, there's a 90-degree angle right there. Okay, and about the given point is that point right there. Okay, so we need to rotate it 90 degrees. How do we think about a rotation? I think of a rotation as kind of like we are going to put some force on this shape and we're going to push it over. Okay, we're going to push it to the right and let the shape fall. But this point right here cannot move. That point is kind of like nailed in place. So we are going to push the object and it's going to fall over. How much is it going to fall over? Exactly 90 degrees. So here's how I always start these. I find a vertical piece or a horizontal piece in the given picture. So in this case, I've got a vertical piece right here. And I make it the horizontal piece so I can see my 90-degree angle right there. And so now I've envisioned the rest of the B. Okay, if the B has tipped over, the new B is going to look something like this. Okay, now I drew this one kind of fast and I drew it on an iPad, so bear with me a little bit. The same shape and size there should be the same shape and size there. But what you should see is you should see this turning of the letter B. Okay, it has spun around the given point. So new example, except this time we're going to go counterclockwise. Everything else is the same. It's still 90 degrees. It's still around that point right there. This time, though, we're going counterclockwise. So this time we're going to see the B fall this way. Okay, if the B falls that way, it's going to look something like that. Okay, let's take a look at one last example. A harder example where we're going to rotate about the origin, which is over here, and not a point connected to the figure. So I'm looking at rectangle ABCD right here. I am not rotating around one of the four vertices. I've got this random arbitrary point here, and I want to take this whole rectangle and rotate it about the origin. Now we are going clockwise, so let's make sure we know what that means. Clockwise, I am going to take my object, which is in quadrant 2 right now, and I'm going to rotate it to quadrant 1. Now we saw this earlier when we take a rectangle and rotate it about one of its vertices, that it's going to change orientation. So not only am I going to change orientation, but I'm changing the location as well. It's not anchored to one of the four vertices. All right, so down below, I've already written some stuff up here. So let's take a look here. The key to a problem like this, when I see rotate 90 degrees, I need to be thinking 90 degrees is a right angle. What does a right angle mean? How do we form a right angle? Oh, we form a right angle by perpendicular lines or perpendicular segments or rays or whatever it is. The key is that I get 90 degrees to a right angle to perpendicular. If I go back to Algebra 1, what does it mean to be perpendicular? Perpendicular, oh gosh, opposite reciprocal slopes. We can do this. So here's what I've got. I've labeled point A, point B, point C, point D. I am going to connect point A to the origin. So let's see if I can draw this on there. Close enough. Okay, I'm starting at point A and I'm connecting it to the origin. I need to find the slope of that line. So you might want to pause right now, but I'm going to find the slope from A to the origin, from B to the origin, from C to the origin, and from D to the origin. I'll let you pause here for a second so that you can check that you can find those slopes. Okay, take a look at my slopes, see if they match your slopes. To get from point A to the origin, you have to go down 7/5. So I got a slope of -7/5. To get from B to the origin, you have to go down 7, but this time only over 4. So I got -7/4. To get from C to the origin, I went down 2/4. And now notice I am not reducing that fraction. Okay, and to get from D to the origin, I'm going to go down 2, but this time over 5. Okay, so we said that the key to this whole problem is to get opposite reciprocal slopes to form perpendicular lines, which get me right angles, which counts for that 90-degree rotation. So opposite reciprocal slopes, we know how to do this, no problem. If I want to find the slope that is perpendicular to -7/5, my slope would be a positive 5/7. Now I'm going to do this for B, C, and D, so you might want to pause here for a second and see if you can calculate your slopes. Okay, let's see. Do your opposite reciprocal slopes match mine? Opposite reciprocal here, we did that one before we paused. Now I found the opposite reciprocal of -7/4 to be a positive 4/7. Remember, you are taking the opposite, which means negative to positive, but you're also taking the reciprocal, which means flip it upside down. So -2/5 becomes a positive 5/2. Okay, all this is from Algebra 1, but let's bring it back to geometry and figure out, what does this mean? What is this number here? What does that tell me? What does 5/7 mean? That means starting at the origin, I'm going to go up 5 and over 7. And when I go up 5 over 7, that's my new point A. Okay, to find my new point B, or B prime, I'm going to go from the origin, I'm going to go up 4 and over 7. To find C, I'm going to go up 4, but only over 2. And then to find D, I'm going to go up 5 and only over 2. Now, before I put those all on here and clutter up my picture, I really want you to see the green lines here. So this was the connection from A to the origin. That was this slope right here. So we said go down 7 over 5. That's what that green line represents. So now when I have the opposite reciprocal slope, the up 5 over 7, I want you to see this progression from A to the origin to A prime. What you should be looking at right there, if you've done it correctly, is your 90-degree right angle. So again, from A to the origin, and then from the origin out to A prime, that's the difference of this slope and this slope, you should see a right angle. Okay, plotting the rest of our points, we can see the right angle from A to A prime. We can see the right angle from B to B prime, from C to C prime, and from D to D prime. So what have we done? We've rotated it 90 degrees clockwise about the origin. So it rotated to the right, it traveled 90 degrees, and we see that it changed from being a vertical rectangle to a horizontal rectangle. That's what I was talking about earlier when I said it's changing its orientation. And there you have it. We just rotated a rectangle 90 degrees about the origin. Good luck, try the one on your sheet, and we'll talk about it in class tomorrow.